one of our main focuses is to really work on this designing of cables. So we propose to create perfect design validation and optimization of flexibles. So what does this mean then? Well, first, every function or every step along the way in this process needs to be able to do their work create as much value as possible within their own group, so to say. And we want to strive to minimize the non-value adding work so that you can apply your skills on solving real world problems and not syncing data and updating CAD and so on. But that's not enough. If you really want to be efficient, then you also need to be able to make sure that the teams can utilize each other's results in a good way. So then we define seamless collaboration between departments, OEM and supplier. And of course, more data will require more power of simulation, but we still strive to make everything accurate and in real time, as it's always been in IPS. You might have seen these keywords for speed, power, and easy to use. So this is the keywords from IPS that we've always stood for. Speed, it means that we want to solve problems in real time as fast as possible. We want to solve more types of problems. So we use the mathematical modeling to be able to solve more problems. But the high degree of mathematical modeling should be in the background, and it should not be to the user. It should look as you are working with a physical product or enhancing your skills. But we also need something else to be able to cover this whole spectra. So we recently defined interoperability as one of our new keywords. So what does that mean? Well, I will take some examples now that on things we are working on and things that you will see in the software soon. But in principle, the interoperability, it means IPS should fit into your digital environment. So be able to communicate with tools that you use, PLM tools, CAD tools, and so forth, and of course, illogical tools. But it can also mean live streaming of results to other systems and so on. And please, if you have any questions during, just pop them or write them in the chat, and I'll see if I can pick it up. All right, so we dive into some features that you will see soon in IPS. So all cases, of course, they start with input and end with output. So one thing I mentioned here is that we need to be able to read, enrich, and write electrological information. So this means that you might know that in IPS you've been able to route cables from A to B quite efficiently to find this collision-free routing and create a cable here with and then setting the via points and creating the first version of one cable, so to say. So if we are to create complete wiring harnesses, that process is still too slow. So we want to be able to read this electrological information and use as input for the design. Then, of course, we need to be able to store the data back to CAD or PLM systems, because you're designing more stuff than cables, of course. We're also developing an interface for interoperability that's more general. So you might have heard of this Lua interface that we've had before. So now we're working on extending that to to something that can connect to third-party applications in a better way, in a more well-defined way, so to say, efficient way. And we're also looking in quite a lot now to supporting more formats of CAD, so triangulated and NURBS CAD data. Of course, when you have brought in all of this electrological data, you will have basically all of the start and end points between connectors throughout the car or the product that you're designing. So right now there is research ongoing, and we are closely watching this research and preparing to include it in our software. So then you will be able to define multiple start and end points. And IPS will automatically branch and position clips on surfaces with with parameters that you specify of clearances and so on. So what happens here is basically you start with a bunch of start and end points. You say to IPS that, okay, I want as short combined, or I want as short total length as possible, or I want as much of the cable to be bundled as possible. So this is a trade-off, and this is what you see here in the Pareto front. But as you see to the user, it's a very simple interface that you can basically switch in between these solutions. And when you have finished creating the design, selected the first draft of it, then the idea is that you should be able to build upon it and take it to a final design. Of course, then through the interoperability solutions, this should be able to be pushed back and forth to PLM systems and electrological systems. So now we're putting some, it's not finished yet. We need to find the right level of input, of user interaction. And of course, since you will be able to create huge cable systems that are woken up or alive, so to say, then you will be able to do simulations that has not been possible before, since it would require quite a lot of effort to wake up a complete wiring harness. So that puts some extra requirements on solvers. So we have a cable solver today, which is world-class in terms of speed and accuracy, but it will not be enough for handling a complete wiring harness that is moving together with the product. We are putting quite a lot of effort here into creating a really completely rewritten cable solver. And already now we see quite good improvements, as you can see from the plots here. So the purple solid line is an example of the new solver then. Some other features when you do validation and production planning in IPS, you have been able before to do automatic path planning with mechanisms, but you have not been able to use these mechanisms inversely. So now you will be able to do that in not the coming release at the start of next year, but hopefully on the next release then. So that will come quite soon. And of course, you will be able to interact with, this will be able to be used together with cables, together with mannequins, and together with VR. Another example of features that you will see quite soon is we are working with the IMA mannequin and joining it with the cable simulation, so that you will be able to interact more efficiently when doing cable assembly, not only with mannequins but also with robotized assembly. So we see these trends that people are investigating cobot solutions and so on. So we want to be prepared to be able to simulate that when you really start to integrate it in your processes. And John, you will do some VR presentations later, I guess. So I'm hoping to that you will like the new features coming. You will see a lot of new VR features in the coming releases. For now, the next release, there will be some more interaction with cables. You will be able to, for instance, automatically create grips and nodes while grabbing cables, and you will get some more visual feedback from the software when you to tell you what you're hovering, so to say, before you grab it. And in the future, we are putting some efforts into, or quite a lot of effort, obviously, to enable multi-user VR. So that requires quite a lot of development and quite new thinking, so to say. So of course, here in VR, you should be able to collaborate and build products utilizing all of the other functionality in IPS, such as automated path planning and interaction with cables. Some other research that is going on, especially in ITWM in Germany, is a lot related to durability. So they are working quite a lot with this absolute lifetime prediction from relative to absolute. And on the Cable Simulation User Conference in Kaiserslautern, we saw some examples on IPS cable simulation combined with crash simulations. It was quite interesting to see as well. Some noise and vibration features will come in the in that add-on module as well, and flexible clips to be able to support this type of grommets and so on that needs more advanced modeling than the bellows and grommets module that we already have today. So some of these features are, or most of these features are steps along the way into creating the perfect design validation optimization process for flexibles. I hope that we will be able to deliver features. I know that we will be able to deliver features that will strengthen the products in the coming years. And thanks a lot for listening.
Yeah, Tom. Are there any questions for Anton right now? That goes for the folks online as well? Yes, yes. I guess one question from me to the group is, I mean, are of the features that he's outlined, are there any that are of particular interest or particularly, exciting? Do they look like things that you could implement into your design processes?
Good afternoon. This is Gaurav from Ford Motor Company.
Things.
Are you able to hear me?
Yes, I can hear you.
Oh, that's great. Okay. So this is Gaurav from Ford Motor Company, and I'm working as a VOME for various trucks, buses, and vans from the electrical side. And we are using a bit of IPS with whatever the limited license we have. And I just want to ask that we are doing a bit of this playing with the flexibles of this routing and hanging positions. But one constraint that we are seeing is that when you try to play with more flexibles, I mean, it takes a huge amount of time. And also, I mean, it's very difficult. I mean, if you take a bunch of big wiring, it really takes a long time and all. I mean, so I mean, have you any plans? I mean, do you have any plans to reduce those? And also, we are also seeking for some automations, like to creating the cables over there, because creating the cables is one of the, I mean, I would say is a basic thing. Whatever we need to do while doing simulations with the IPS. So if you're able to do some automation, just 1 or 2 clicks, and all the cables will become flexibles. So I think that would fasten or that would make our process bit easier. It will be bit easy for our engineers to apply this IPS into our electrical cables. So what are the plans of that? If you could elaborate a bit.
So thank you. Very good questions and very relevant questions. I can confirm that I also see that problem, that when you grow the problem right now, you will have a quite, as you see from the plot here, quite linear scaling, and then the performance will go quite down quite fast, so to say. So from the plot on the screen now, you can see the performance of pretty much the current solver on the top line. So this is a computational time versus a number of cable segments or grid points. So the new solver that we're working with now is aimed at exactly that. That when you have the capability to create huge systems in an optimized way, you will, if you have the older solver, you will directly run into problems when you start interacting with the cables. So therefore, we realized that we need a completely new solver that is many times faster and more efficient. And related to your other question about automation, I think this is one of the automations that we're working on. So automatically creating the cables from the electrological data then. So if you're working as a manufacturing engineer, for instance, then typically you would take CAD geometry and start waking up branch by branch, right? Or you have the possibility to wake up several cables in a row, but you still need to wake them sort of one by one and then connect them. The idea here is that if you start to actually creating all of the cables inside IPS and feeding that data to your PLM systems, there will already, from the first version of the CAD, there will already exist an IPS model that is linked to this part then. That all of the downstream functions would be able to utilize way more efficient. So the goal here is that no one should be able to, or no one should have to wake up a cable ever again.
Yeah, I think that's good. I think that's what we're looking for, because that would help us a lot. And maybe one more question I have to ask. I mean, I think there are also other people to ask questions, but one more question, like when we have various kinds of cables, right? We have got the high voltage cables with various sleeves, some with copper, some with aluminum. We have got coax cables. We have got the low voltage cables, and it depends on, and stiffness varies, right? So do we have, I mean, I know that we have got few items where the materials are already there in the IPS, but I think coax or the Ethernet cables, these are the ones where we don't have a material specs. So is there a plan, or is there a plan in future to get all these into the IPS, like the material properties, including like what kind of things the OEMs are using? Is there a plan to include all the material properties into the IPS cables?
Also a very good question, and there are quite few different activities going on here. So is there some colleagues from fleXstructures Germany here to fill in maybe? But anyway, we're working together closely with fleXstructures Germany here to develop this system to provide material properties for cables and bundles then. So we already have this bundle properties estimator where you define each component in the bundle, so to say, and it will calculate automatically a combined material property for that bundle. Of course, in the example you see here on the screen, then all of this information to feed the bundle properties estimator will be available to the software. So when creating this cable, you will get the right material properties directly, because the electrological information, it will know what wire goes from bit 1 connector 3 to bit 7 connector 13 and so forth then.
Yeah, thank you. Thank you very much.
Anton, we had another question in the chat. It says, does the kinematic package involve the creation of joints, prismatic and revolute, and degrees of freedom? I believe, correct me if I'm wrong here, but I believe that the current mechanism creation tools in IPS and the mechanism path planner, you can create prismatic and revolute joints. It sounds like what's new is some inverse kinematic functionality. And then to add to this question, and I believe we talked about this when we met in Germany, but is there going to be a capability to create more complex kinematics like 4-bar links and things like that?
In the first version, then you will have only prismatic and revolute joints, but we will expand it in the release after, or at least very soon after, we will expand it to ball joints and all different kind of joints, so that you should be able to, in principle, build complete suspension systems with this.
Great.
Very good question.
I got a question.
Sure.
Hey, Anton, the interoperability that you mentioned, and you talked about Lua, which we're familiar with, but are you thinking of a plan for like a bridge to bridge for certain CAD softwares? Or are you thinking more of a generic hub that would share the data? It wouldn't matter what it came in from, wouldn't matter where it came out of. You basically pick the flavor of what you want, I guess. So, like, I know back in the day when we first got IPS going, we did the old JT Open Toolkit. So, in order to get the data from CATIA through the Biz mockup system and into the IPS tool. So, are you looking for specific software to software bridge, or are you looking at more of a generic bridge?
Yeah. Good question, and the answer is actually both. That we are looking into a system, especially fleXstructures Germany, or developing a system sort of out of box interoperability called FlexHub that will link to specific PLM and CAD softwares. But we're also, as you see here, the interface for do-it-yourself interoperability. So that means that there will be a clear interface that we deliver with the software, so that OEMs or OEMs supported by us or fleXstructures will be able to create custom interoperability with your systems. Because I know PLM systems can look in any type of way at a given OEM site, right? Okay, that's the question.
Chris? Yes, that's good. Thank you, Anton.
I guess I have one more question. So Anton, you had mentioned starting the flexible design in the IPS instead of the CAD tool. So it seems like IPS is limited, some of the selections of the movement and assemblies, different things like that. So as this next version evolves, will it look more CAD-like, the ability to be able to create your flexible within the CAE tool instead of having to go from CAD back to CAE, then back to CAD?
Mhm. I mean, when you mean CAE in this case, what type of CAE do you mean, like crash type simulations and that type of simulations, or?
Kind of use the word CAE very generally, but I'm referring to IPS. So instead of having to design a CAD tool that doesn't handle flexibles at all, to then have to take that backwards into IPS, do the simulations, and then take the results and bring it back to CAD. I think you're referring to start from scratch in IPS, somewhere that's well suited for flexibles. Do your analysis, then the results you bring into CAD, so you're not having to do this back and forth. Are there tools that are being developed in IPS that will be better suited for those types of things?
Yeah. So there's a number of things that needs to be in place if you are to design a complete wiring harness. Of course, you need access to databases of clips and connectors, and you need some way of designing cable channels and all of these surrounding parts, right? You also need to be able to fetch and push data to CAD and PLM systems in a seamless way. So we understand that, of course, not the complete product will be created inside IPS. We are not a CAD tool per se, but for specifically wiring harnesses and flexible hoses, like cooling hoses and so on. We think that we are in a strong position to be able to deliver that, so that you can create cables and hoses from scratch in IPS and then feed it to the downstream systems and back to the upstream system, of course. Of course, interested to know your feedback on all of this, and please talk to Carl and fleXstructures and Sandalwood so we will capture all of the thoughts here, how this will suit into your processes.
Yes, Anton, and as a matter of fact, at the when we wind up the afternoon here, Mike and I are going to engage in a lead a feedback session to gather impressions from today, as well as other features and suggestions from the user community here. So you'll be hearing from us.
Sounds good.
I think we've got another question that's come in.
Yep. So one last question from the chat. Would like to know if the IPS team can incorporate tolerance of hoses in the base segment option, such that the entirety of the analysis can be done with nominal and with tolerances. So if I'm understanding this correctly, you're asking if the tolerance of a particular flexible can be directly incorporated into the create flexible tool rather than using like a tolerance envelope or something like that. Let me know if I got that right. Okay, yes.
It's a good point. Like you mentioned, we have the capability for tolerance envelopes and for varying angles and lengths and material parameters and all of this from before. So it's a good point to have the option to include it on everything at once, so to say, in the creation process. That would be a reasonable thing to do, if the user wants to, of course.
And then one more. And unfortunately, I appreciate all the participation, but we're running short of time.
I'll keep the questions.
Okay, all right. Carl's gonna donate some of his time. That sounds good. So this question says, why does the bellow creation process not available in the latest IPS version and only available in older version. Any specific reason? The bellow finder is still available and widely used. So I don't know if that's a licensing issue. We're actually going to do a demonstration of the bellows and grommets tool during our session here today. So I guess if there's any specific functionality that you're missing, please let us know, but we'll be talking through that. But it should be available.
Sounds good. Sounds good. Yeah, it should definitely be available. I can see from the version number here that it's quite some years old. So I don't have I cannot remember from the top of my head now what it looked like in 3.11.2 actually. So, but for sure, let's look into that.
Okay, great. Any other?
We're
questions?
actually looking into a more general. I mean, behind the bellows and grommets measure, so to say, or when you create that mesh, you assume that there is a circular cross section of the bellow or grommet. So we're actually looking into a more general meshing algorithm here that will, so you will be able to simulate general flexible surfaces, for instance. But that is a bit more in the future than what I mentioned in my presentation.
I don't know what feature you were presenting before, but it was related to installing a flexible. The user was handling it. One of the aspects where we fall short with designing a part purely virtually with IPS brake hose is manipulated conditions where if the brake hose were to maybe get hit by a foreign object inadvertently and then move out of position from design intent, or what it would naturally would be, and then maybe hook itself on a component in the suspension and maybe not relieve itself, maybe end up being under tension as the suspension continues to move. Those kinds of things we don't really have capability to measure or to evaluate in IPS. So I'm wondering if you could see something like that, some sort of way to approach evaluating that in the future.
It's a good point, and we'll have to look into the details of what needs to be working there. I mean, I'm guessing that it's some kind of dynamic effect that will lead to this strange movement of the cable. So then you have there is a dynamics module that will take into account this inertia effects and so on, so that you would have overflow, or what do you call it? Inertia effects.
Or overshoot.
Yeah.
Particularly when we evaluate, of course, we're not just looking at a car or a vehicle. I'm sure of course, there's durability reviews, but during routing studies, you're typically just going to grab the part, see if you can easily hook it onto things with your hand. So maybe that could be just one approach for you guys to consider. I can grab the part and maybe move it, and then it maybe stops me after a certain point of tension. You know what I mean? Then I know, okay, well, I'm not stretching the hose. It can't easily get there. Sure, does it make sense?
Well,
I understand.
is this
That's a good point.
is this more of a manufacturing feasibility studies?
No, it's purely the design process. It's just something you can't look at till you get a full vehicle on a hoist. Usually, or mock-up suspension.
So like taking an installed hose and trying to see where can it go, basically, from all possible forces.
Yeah. What's the zone in which it can go without so much with very little tension applied, and can't wrap around something and get stuck.
Right. There is actually a function for it's similar to tolerance envelope, but it's called force envelope, that you basically apply a force along the cable in all directions or in specified directions and sweep the volume where it will has the possibility to go. So you can look into that and see if it answers your question. Might be something similar at least.
Thank you.
We have another question here. Do we have options to check the effects of fluid flow in hoses during the simulation in IPS?
We have worked a little bit with scripts. We've got this question many times, and you cannot simulate the actual fluid flow inside the hose and see how the cable is affected by that. But we can change gravity or change length density in an automated way, so to say, to calculate the volume that will be contained by fluid, then, so that the cable will have a different shape affected by this gravity effects. And also, I think from the top of my head, I'm not exactly sure how it's done, but somehow affecting the material parameters at least. But we can look into that, of course.
Thank you.
I appreciate all of your questions. Nice to hear the enthusiasm.
Yeah, it's nice having a kind of a smaller, intimate group here. I think we're asking more questions, and I remember in Germany, the conference hall was a bit intimidating for people to ask questions, early on. But it's good to get the kind of feedback here. Great. Well, if there are no further questions, thank you very much for your time and staying up late in.
Thanks a lot for having me, and I'm looking forward to joining in person some year in the future.
Us too.
All right.
All right. Thanks a lot.
And I'll go to share find it. Well, so as you can see, the development of IPS continues, and we're really pleased about. I think I'm speaking for Mike and the Sandalwood team as well. Is that it's a question that we've been getting from you, from our user community, a lot over the past years that we've been active in North America. Is and maybe it's a North American outlook, but we want to know what's coming. What's the future looking like, and in the conference itself, Anton presented at the roadmap at the conference, and that's why coming off that, we really felt it was important to have him share that with you all as well. So that even if you couldn't make it to the conference, and I'll touch on a few highlights here, but to let you know that this input is being collated, put into a release map, so that as you get notices, we're planning the release 2024 R1 is due to be released in December. We're currently starting off with some user acceptance testing as well, so essentially beta testing out in the field. If that's something that you're interested in participating in, let me know. I know it's not totally productive. We impose on you a little bit to kick the tires and such, but if you've got some extra time and are interested, we'd appreciate your feedback and your chance to have your voice heard there as well. So with that, I'll just touch on a few highlights of the conference. It was held in last month, September, for 2 days. I think was the 13th and 14th. Led off with some advanced. If you do have an opportunity to get over, the next one is being scheduled for May 2025. So it's going to be 2 years before there's there's another conference held in Europe. Date or the location is TBD. So I believe the previous conferences were held in Germany. John, you'll
I think it's Bushfire. Yeah.
Right. So there's some talk of perhaps since it's more toward the summertime to perhaps have it in Sweden. And Gothenburg is a beautiful city. So stay tuned. We'll let you know what's going on there. It was held. Oh, why do I have that?
I thought I was gonna let you know, yeah, put it in presentation mode.
Come on.
We're on a roll, Carl. I didn't want to
I'm done now. Yeah, so it was held in the Fruchthalle, the fruit hall, market hall in Kaiserslautern, which and the folks in Kaiserslautern generously set up a work zone all around the building. So it's really impossible to get to, but the interior was really gorgeous. Central location in Kaiserslautern. The history. Klaus Dressler, who is the manager of the team, he's with Fraunhofer Gesellschaft, and he was part of the team at the Institute of Industrial Mathematics that first came up with the idea, the initial work on the equations and so forth that would become IPS cable simulation. So Klaus, get him going on a beer. He's a font of history, and it turns out that in that hall in 1848, there was something of a people's uprising under the various duchies and kingdoms of Germany to try to turn Germany into a bit more of a democracy. They've seen what's been going on in the U.S. for the past 60 years. So there was a meeting of started in the Rhineland-Palatinate, so that that's a province of Germany along the Rhine, along the wine road, if you can make it over there, which is gorgeous. And they actually spearheaded the effort to draft something of their own declarations of independence and constitution to try to break away from the monarchy, and got crushed a year later. But they made a go of it here in starting in the fruit hall, and that would eventually take a couple of wars to get Germany into an active democracy and get rid of the Kaiser. But Kaiserslautern prides itself in having played a role in some of that. But it is a gorgeous facility. And over the course of 2 days, we had a number of presentations. I won't go through all of them. I just wanted to hit on a few highlights. If you'd like to know more about them, we generally do not distribute the conference proceedings in that form. That's something I'd like to see happen, so that you've got access to it. But if there are particular things that are of interest, please let us know. I believe it's still available online. We try to get the information out to you, but a mix of user presentations and then presentations like the ones that Anton gave as well, talking about product development and roadmap. One of the things, so touching on the first one, and Anton mentioned that there is a fleXstructures component to this, and it was kicked off 2 years ago. It was a project called BoardNet Sim 3D. So you can actually find it online. And it was it came about actually during COVID as the German Ministry of Commerce was looking to promote business in the area. Fraunhofer, together with fleXstructures and a business partner, in this case Volkswagen, has joined in, is looking for a way to automate the movement of electrical logical data into a form, into essentially simulation environment, and streamline that entire project process. So that's where that project is called BoardNet Sim 3D. It's going to be coming to a close a year from now. So it'll be after that point. We're actually going to be limited in our marketing. I'm not marketing this. We're, as part of the conference to explain the sort of things that are going on. And, we'll be at a point where I think some user or worldwide input will be needed as well. One of the point here, and Germany and Europe are quite well positioned for this also, is going from the electrological side. There are already data formats that have been adopted, particularly among the German manufacturers. Hopefully that's something that we can belong onto here once the dirty work's been done. So the KBL format is used for transferring wiring data. That's going to be superseded. I believe there's a new format coming up called VEC for vehicle electronic components. But the idea is being able to take that and really use that to feed the pipeline of different use cases as electrical harnesses are made. So that includes going from this design into a variety of different usable models, in this case IPS models, to do cable simulation, installation studies, have a connection to a database, which in itself is going to be the component piece that we'll be talking about a bit more in the future, called FlexHub, an interface to your database so that we can get different wire types, different connector types, clip libraries, and have that all in one central place so it's available to you to work with. And then on the output side, bring it to the pieces that you can use, such as form boards, and to really help to streamline that the design process for electrical wire harnesses. So that's and that has spawned off a lot of related projects. Anton, you heard him mention the bundle properties estimator. There's work that's been ongoing also with wire manufacturers in Germany. Our friends at Livonia have been quite active there, as well as Coroplast, B-Wire, sending us samples. We're doing we being fleXstructures Germany, doing insomnics measurements, characterizing what the individual strands are doing, and using that to help validate our bundle estimator. So there's an improved version of the bundle estimator that is going to come out of the BoardNet Sim 3D project as well, so that you can take the pieces and put those together in novel arrangements, and have be assured that that things are going to come together the way you like them, and get the properties that you need. We do have a white paper available for that online, so if you need help finding it, you can get that. But this has been exciting work because it has brought into into focus a lot of the needs of industry there. Another presentation that was done in our people sessions was looking a bit more at damage and fatigue. In particular, being able to use ruler curves, the SN curves, directly within IPS in a form that we can start to do fatigue life cycle estimation. So right now, some of you may have used or heard of the durability and dynamics module that is already available as an add-on to IPS cable. With that, by including mass of the cable to get inertial effects and damping, so that we can model vibrational effects. We already have an ability with that to simulate how the cables are moving dynamically. In particular, we've got a white paper on this also. Folks at Daimler Trucks, for instance, noticed on their high voltage applications, the relative motion between the high voltage wires going between the battery and the e-motor. You'll get different results depending on whether you're simulating in the standard quasi-static mode, where the weight kind of hangs off of the connectors and you see more of the damage at the connection side, versus what's happening dynamically as the hose flexes and you see more damage along the length of the hose. So we already provide you an indication of where to go with that, with pseudo damage calculations. But the goal here is, and this has been supported by our at Gebauer and Rüda, and developed a number of test fixtures to do different types of stress tests on cables, doing torsion as well as moving them, flexing, unflexing, doing recording cycle times for the different types of cables, and being able to use that information in this an eventual enhanced durability module, if you will manifest itself as a project or a product. But you know, in this case, and there, yeah, sadly, I don't have the animations for this, but looking at different you know, vibrational tests and getting the actual measured data to be able to compare that with some of the work that's or output that you can get out of this durability module in IPS cable. So that's seen as something that's very critical moving forward. And yeah, the hope is that we can get to absolute lifetime prediction, you know, when you've got SN data for the cables themselves. So that generated a lot of questions and interest. And again, these we're trying to work directly with with cable manufacturers so that that this type of information can be brought to you. Another IPS user and cable manufacturer, Livonia, gave a presentation about this effect, you know, dynamic simulation, dynamic loops for cable applications. Here in particular, they were looking at again the high voltage cables for an EV, looking at things like the actual routing locations, contact analysis, some elementary fatigue. This is not using the SN curves yet, but looking at some pseudo damage fatigue calculations, and using that in particular to look at challenges related to shielded cables. In particular, you've got this, what is it, catch-22 when it comes to shielded cables. You know, you want them shielded for particular applications. However, it does end up making them stiffer, more prone to damage. So how do you find the right way to go there? So they've done a number of simulations there, correlations also to standard models. Because they make their own cables, they are looking at different types of materials where they can use interleaved insulation layers between copper and aluminum. And yeah, just the catch-22 here. If they see damage to shielding, it creates a stiffer cable. But if you use other methods, use other materials, then you can get more damage at the fixation area. So that work is ongoing as well. But it's quite interesting to see what Livonia is doing with IPS cable. An application that I didn't see coming at all is from the folks at Nexans doing simulation of the clock spring module, which I didn't know that the car had a spring until my daughter needed it. Get her the airbag light that came on her Nissan, and we took it in. And that was part of the diagnosis, was that it needed a clock spring. Thinking, I don't know where to wind up the car. I never need the clock spring, but sure enough, there it is in the steering wheel as part of the communication between the the column and the wheel itself and the airbag module on it. There is an IPS cable module. We mentioned bellows and grommets that we're going to talk about. There are a number of other flexible structures that can be simulated as add-ons to it. In this case, the innards of the clock spring, in case you ever wondered, how does it communicate while it's twisting around? Was it 3 turns lock to lock or so? Is through a set of these ribbon cables that communicate between the portion. between the inside and the outside. This application too, the woman who was engineer who was doing the work on this, she was also very happy to hear from Anton that new solver technology is coming on board because due to the just a large amount of contact and the fairly small mesh that needs to be used in order to simulate this, she was getting some pretty high computation times. Well, so but ultimately the flat cable element in IPS was bearing fruit here, and it's an interesting way to non-traditional, I'd say, versus some of the other cable applications you see typically. So something to take back and share among the team. We had a very good representation by folks from the off-highway community, construction and agriculture. Longtime user, John, you probably know Ulf Hefner of John Deere came, and his line to start with was IPS cable is a lifesaver for off-road vehicles and the work that they're doing. So he presented some work that John Deere has been doing, really drilling down into areas where they're feeling pain in the business. A lot of that because they have such long such a long amount of time in the field, right? Some tractors and airplanes, folks at Boeing tick totally differently than we do here in Detroit, because they've got to be field operational so long. So they're able to take really a deep dive and look closely at warranty failures, try to use IPS to come up with creative ways to fix failures that they're seeing in the field, and really been able to quantify values. Unfortunately, we don't have dollar signs here, but really we're able to help lend that to the justification of expanding the use of IPS cable, and now also IPS EMA for ergonomics in the field with what they're doing. And again, confident enough, since they are longtime users like many of you, where the issues can be taken care of directly with IPS simulation and avoiding a lot of expensive physical testing. Was that? Yeah, I think that was the slide there. There was another presentation. The folks at Case New Holland out of Italy where they're presented some of the work that they're doing also. And then there's another team out of Sweden, a consultancy that presented some of the work that it was doing to validate hydraulic hoses and come up with values for stiffness under different operating conditions, and that kind of touches on some of the topics here, and was wrapped up quite nicely by Leap here. They were the final presentation of the conference, where as part of their validation process, Leap here went in very deep and did 3D scans of their hoses, and they've got these massive number of hydraulic hoses that they move along and articulate. And doing 3D scans and overlaying them. Can take one of the input data formats is there's the XYZ and the 57 file formats to read in point cloud scans and overlay those and compare that to what you're doing in IPS cable simulation. So they've used that as part of their internal validation process. Got tremendous results with that. I believe our colleagues, our distributors in Japan, also had a similar heavy equipment. Hitachi is a user, but really just to it's good to see all these different applications where the use of what you're getting from IPS cable simulation bears out really with the real world. So as you see, it did end up generating a lot of interest and discussion about hydraulic hoses. One of them getting to properties. Now, we've mentioned the Masonics measurement system before. That was developed at Fraunhofer really cable. We come up with this novel computational strategy to simulate how the cables work. How do we get the properties to do that? So fleXstructures, we have our own Sonics machine where we can test wires, harnesses up to about 40 millimeter diameter directly in-house. Fraunhofer, being the mothership, if you will, has a much bigger lab, which if you get a chance to see it is impressive, to measure hydraulic hoses, I think up to 300 millimeters diameter, and they're going to go up to 500 bar pressure or something. We're doing in the hundreds now, but going into the thousands. I mean, it's amazing, together with a heat chamber and a cool chamber as well. So you get those different types of operating conditions. So, yes.
Oh, quite a bit over already.
Oh, am I?
Yeah.
Okay. Then I think this is the last one, I believe. And yeah, I was just going to wrap up. One of the things that did come out going to the questions about the hydraulic hoses also is that a rule of thumb that Liebherr found out that others are kind of too as well, is that a hydraulic hose under pressure is roughly about a factor of 12, roughly an order of magnitude stiffer than it is without the pressure running into it. So the note to the extent
later.
Right. So which, yeah, and a few more cool plots on where they're what they're doing over at Liebherr, and that's it.
Awesome.
You got me right. Right in the red. No, that's okay. I was trying to do that with oh yeah, we're a bit all right. I usually keep my stopwatch going here. So anyway, if you do have any other questions about what went on over there, I think there are a few presentations that we can share, and hopefully we'll see you over there in a couple of weeks' time. So with that, Anton had provided a roadmap of what's going on in the future. As he said, some of the work that originally was done with particular IPS cable dates back over a decade, and someone who was on the ground here to see that was John Orchek. So we asked him to say a few words about how we got to where we are. So
I don't know if I could do it in a few words. The camera here.
John.
So my half-hour speech, I put it on 10 minutes. My name is John Orchek. I work at Ford Motor Company, so I work with Chris Hurley, Bruce Donovan, Mike Reimer online, a lot of the people that are online, and I've been at Ford roughly 10 years, but I've worked alongside Ford for my whole career. Previous to Ford, I worked at a no longer existing wire supplier called AFL. Kind of like Livonia, Yazaki, one of those kind of things. And so we've always worked with wire harnesses. And one of the areas that have really kind of intrigued me, and Bruce is very detailed and knowledgeable about this, is running flexibles in a CAD tool. They look pretty, they look blue, they look perfect, but when you put them in the vehicle and they don't work. And so under Chris's leadership, when we were in the EDS department, he started a relationship with IPS and Fraunhofer, Chalmers, to kind of look and say, well, I think there's something here. Ford was using and still uses IPS in our advanced manufacturing in Sandalwood. I think you're part of that too. And so he started to look at, well, if we're using this tool for these other areas, maybe we can try to use it for flexibles. And so that's kind of how we started engaging IPS. So it's been probably over a decade, maybe a long years or something like that. So we've seen it come a long way from literally having to open the model and break down all the motion and remap it. So you didn't have little red bolts and it'd take hours. So now it's come a long way, very streamlined. It's a sales pitch, believe me. But it's just been a good working relationship with them. So currently I work in what's called systems engineering. So I see the work out there. So it's been a buzzword that you've heard in the industry, but really from Ford Motor Company, from a flexible standpoint, when we say systems engineering, at least from a flexible standpoint, you're looking at things holistically. So you're not just worried about wiring, you're not worried about just cooling hoses, brake lines, you're looking at all of them. So how do they interact together in the vehicle? So it's not really to the benefit of one commodity or the next to design your part robustly if the other part suffers because of it. So working along in systems engineering thinking, that's what we do. Is we bring in all of the other flexibles and as parts are designed and simulated, we look at what is the effect? Can another part possibly change to help our part? Can we modify something in our part or around it to help somebody else? So the company itself benefits from those kind of holistic synergies between doing those kind of things. Let's see what else I have here. Well, I ran through a lot of that. So, like I said, flexibles, and it's been mentioned, it's not just wiring, it's climate, it's cooling, it's brakes, it's transmission, cooling line. Bruce and Mike Ryan were on the line and worked with wiring for a long time. Even Ethernet cables, transmission shifter cables, anything that moves, anything literally that in a CAD tool, probably rounded, it looks like it's stiff, but we know it's not. A lot of the other departments, let's say, they're hard parts as we refer back to them. You put them there, they're going to stay there, you bolt them together, you can do a lot with that. Flexibles, you're kind of always predicting. I was thinking about this last night with, I don't want to say we're weather forecaster, but we're saying it should do this, but it could possibly do this, could possibly do that. So how do you predict it? How do you show to the other commodities vehicle that we're going to try to be as realistic as possible with our designs that way? So that's something that we continue to kind of preach at Ford Motor Company of working at this from a kind of a holistic approach that way. So that's a good thing. So the other thing too is incorporating IPS with our different development phases. So the different milestones as we hit them throughout the program cycle, that we repeat the analysis of the design to make sure it's robust because parts change, different things go on different directions on a program. You don't just assess the flexibles once, but you repeat that at certain milestones. And even to introduce, as Bruce had worked on in the past, certain failure modes. You had mentioned, what if the brake hose gets caught somewhere? What if from a wire standpoint, the operator forgets to put a clip in? What would happen at the end of the line when they drive that vehicle off the line that way if they missed one or two of them? So it's all of this kind of what if scenarios that you're trying to simulate through IPS that way. So, and then Lewis scripting. Lewis scripting has been a great benefit to us within the tool to be able to develop Lewis scripts for repetitive different types of processes and also try to bring together multiple different commands together where you could kind of push a button, the script, you would go through and it would execute, you get the results of that, and then you get that exported to your PLM. One of the areas we're looking at are tolerance envelopes, motion values. It's kind of, we have a tool in our existing CAD tool that'll show like a zone, but IPS has many, many more features within it to be able to tweak those kind of zones and get them more realistic. So we're working with that as well. So comes to the sales pitch. So our relationship with IPS is that I think the partnership. Really, Chris can speak to that. I won't name other large companies we've worked with in the past, but it's really kind of you pitch out an idea and they turn around and they say, well, let's give you a quota, or it's immediately, how much money can we make off this company? Where when we talk with them, it's kind of like a give and take. We're asking them to help us, and then by them helping us, it's helping them again because they can expand their user base. So it's really kind of a partnership with IPS and Fraunhofer and Chalmers and everybody over the years. So it's been a great relationship. One of the things that I was kind of jotting down notes here is, we have people from different OEMs, different companies. And instead of looking at it only from like Ford specific or something like that, if anybody's familiar with US Car, it was kind of let's say a noble, organization that was created to say, we're not just going to treat this in a vacuum and we're going to develop stuff for us, but how do we look across the industry for flexibles? What kind of standards can we come up with? What kind of improvements that will benefit everybody in the transportation industry and these different industries that way? So that's something that I think we probably need to talk about more. How could we get that started, get that rolling, not just kind of like in pockets, but more of across the board that way. And then lastly, thank you all, and let's all work together to form synergies across commonly shared colleagues and solutions where IPS can add value to the company. That's it. So I got it.
Oh my goodness.
No fancy slides. Thank you.
That was great. Thank you.
So, and that is, and you all have, I think some of those relationships predate fleXstructures, right? And it's going back into, was it 07, 08? What have I heard?
It's probably around that time. I'm trying to, because I met Klaus at their facility.
Okay,
I met,
okay.
who's the guy who does the sales? Oh, man.
Giannis, Giannis Litzopoulos.
It doesn't matter. But anyway, I met those guys there and they were showing me their facility.
Mhm.
But it was very early on and they were trying to describe how fleXstructures was like one portion in certain countries and Chalmers was the other country. So, but it sounds like the partnership is there. And like you said, the Goldberg, what I used to forgot what I used to say in the US, they have their mathematics institute, they do their like development there, network, we have a really good relationship. We actually created some projects and stuff, but we kind of got up against it. So I think to John's point, I think we as a community need to kind of like, if there's things that we all need, and we can kind of make that list, they're really quick to say, hey, if everybody wants the same thing, we will change our development. So I think it's a big win for all of us if we can kind of get on that same page and do that. So yeah, like you said, it started in advanced manufacturing and we just kind of latched onto it. We did it as a lot of like, something went wrong and we do a study and go, oh, if we would have done this, we would have caught it. So we're like, well, this is dumb. Let's try to do it to not come out right. But that was like a slow moving. How do you change that mindset? How do you get that in place? And it's been many, many years of getting there. So in pockets.
So yeah, cuts down the second iteration significantly.
Yes. So we've come a long way. We still got a long way to go.
Yeah.
They keep on with it. Maybe the goalposts on us. Changing software is like everything else, but it's encouraging.
Yes, and it's especially, since we're in the spot where there's so much more attention focused on the path to the future, which is includes a lot of EVs and what we're doing there. A couple of presentations that were at the conference that I didn't touch on because they did get pretty technical, but worth mentioning also. And again, this is Klaus's team. If you ever met Fabio Schneider-Jung, he's the one that's working on the new cable formulation. So to achieve those simulation targets. So that was big effort. Another thing that he's got his fingers in everything that's higher math. That also includes noise transmission in particular on hoses and cooling hoses. So looking at vibrational transform there. So that's an area that's got a lot of interest. And then together with the team in Italy, they're actually looking at ways that that crash simulation can be coupled or used in some way. And it's the topic that was presented was not really a co-simulation, but this idea of you've got let's say a model of your vehicle before and after a crash, and somehow overlaying that with your known cable layouts and seeing where volumes of interference have occurred, where you might have to find an impingement. Was it enough just to move the cable out of the way, or is it going to be cut in some way? Live wires are never good. So and what can be looked at there? So there's a lot of research going on in those areas as well. So I think
we blew up your time.
No,
You're fine. The comments.
Oh, there are more.
Yes.
Okay.
No.
I think we're ready. We've got one of our remote presenters here, Manuela. Are you on the line?
Yes, I'm here.
There we go. So I'll say a few words. I'll let Manuela mostly introduce herself. Met obviously last month. attend the Applied Human Factors and Ergonomics Conference in San Francisco at the end of July, where she presented some work that she had done formerly as a grad student, and now as a member of fleXstructures Italy. And I'll turn it over to her to present the work that she's been doing on the virtual manufacturing side.
Thank you, Carl, for the presentation. So I'm gonna share my screen. Okay, can you see it right now?
Yes, we can see your presentation.
Okay, perfect. So as Carl was saying, I did this presentation for an ergonomic conference in San Francisco. So it was a project that we developed together with an industrial partner, which was Whirlpool, different universities there in Italy, that was Politecnico di Torino and Unimore, and different research centers that it was Fraunhofer, Chalmers, and ITI. So the title of this project was Assessing Ergonomics on Cobot for an Optimized Integrated Solution in Early Phase of Product and Process Design, the Integrated Methodology Approach of IPS Robotics in combination with IPS Digital Human Model IMA. I think got it. Okay. So I'm going to start with the introduction. So human-robot collaboration is becoming a hot topic nowadays in the manufacturing industries due to its potentials and benefits that brings to the process and also to the human health. So some advantages that human-robot collaboration brings is that, for example, robots can take over complex and physically demanding assembly tasks. It also helps to reduce the biomechanical workload and increase product quality. However, it is important to take into account when we are designing a hybrid cell, the task allocation between workers and cobot, since it may affect the performance of the workstation. So when we are designing a hybrid cell, it is important to take into account and to avoid high mental load on workers and a decrease of the efficiency. So it's here where digital human model software plays an important role, since it may help the designer, for example, to identify possible criticalities between the collaboration of the robot and human, also understand how it could be the collaboration between the robot and human, and also it gives the possibility to the designer to evaluate what-if scenarios. So before diving into the main topic of this project, I wanted to talk a little bit about how manufacturing industries perform their ergonomic evaluation nowadays. So what they normally do is called corrective ergonomics. So it's perform ergonomic evaluation at advanced stages of the design process, normally to a demo station or to a already built working place, where times and costs are high, and also it's difficult to perform what-if scenarios and optimization cases. So the aim of this project was that we propose a new methodology that guides the cell designer to develop a hybrid workstation considering the individual characteristics of the human and also on the robot through the definition of a performance index at the early stages of the design process using a digital human modeling software. So the methodology that we propose is that first the designer needs to analyze the task and then breaking down into any small activities that we're going to call atomic operation. Something that we recommend is using this kind of diagram where the designer needs to allocate the different atomic operations to the different blocks, and then with the arrows connect the different blocks to give the sequence of the activity. Once we identify these parameters, we need to allocate each of the atomic operations either to the human or to the robot and then create all possible scenarios. But then the question was, how are we going to identify which is the best possible scenario? So for that reason, we propose a cost function. So what is a cost function? It's a formula with different parameters that are normally important to take into account when we are designing a hybrid cell. So for example, the time required to execute each atomic task that can be done by the human or by the robot, also the ergonomic index, And then each of these parameters are multiplied by a weight. Normally, this value is given by the designer according with the importance of this parameter in the activity that he or she is designing. For example, for our project, we use IPS platform to identify some of these parameters to be able to then perform the cost function and to identify which was the best possible scenario. So as I told you before, we use the IPS platform. In particular, we use IPS IMA and IPS robotics that give us the possibility to perform the simulation of human-robot collaboration in the same environment. And as ergonomic evaluation, we use EAWS that was already implemented inside IPS IMA. Okay, so we wanted to verify this methodology in a real work scenario. So for that reason, we took like a use case that it was the transformer assembly station in the microwave factory at Whirlpool. And we also performed the simulation of it. So as you can see, the robot, so this workstation that you are seeing right now is how is the workstation right now. That is actually a human-robot collaboration, a hybrid workplace. So as you can see, the robot picks the transformer, then places the transformer on a table in front of the mannequin, and then the mannequin needs to pick that transformer and then perform the assembly of the transformer inside of the microwave. And then the mannequin continue with the fixing activities to fix the transformer inside of the microwave. So as you can see, we perform the simulation of the assist scenario to be able to compare the current solution with the solution that we're going to find out using the methodology that we are proposing with this project. Okay. Oops. Okay. I think. Okay, so after we apply this methodology and we find out which was the best possible scenario, we identify the optimized solution. So we simulate that optimized solution using IPS platform. So as you can see, we also changed the grip system with a gripper in order to make easier and safety the collaboration between the human and the robot. And as you can see, this is the activity. So the robot picks the transformer. Okay, the robot picks the transformer, then present the transformer. Sorry, then no, what is happening? Then present the transformer to the mannequin. Okay, the mannequin grab the gripper, and then in that moment, the way of functionality of the robot change in order that the mannequin is able to guide the robot inside of the microwave and then place the transformer in the correct position and then continue with the fixing activities that we were seeing in the assist scenario. So with this optimized solution, we find out that it was an improvement since we saw that a significant reduction in the operator's workload. So the operators didn't need to hold anymore the weight of the transformer. So in that way, we were able to remove the manual material handling activity. And as a consequence, we improved the ergonomic score of the task. That was one of the main aspects that we needed to improve in this working station. So the use of IPS platform gives us the possibility to perform the human-robot collaboration simulation using like one scenario, one environment. Also, we create a family of mannequins that represents the target population. So Whirlpool's workers that were actually working in that working place in order to find out anthropometric mismatches. So as you can see, the small mannequin is working with her hands at shoulder level, while the tall mannequin is working with a more comfortable position. So in this way, the designer is able to identify which workers should be allocated in this working place in order to have a low ergonomic risk. Additionally, we were able to perform proactive ergonomics, so take into account ergonomics aspects at the early stages of the design process, and we were able to perform EAWS evaluation, that it was like a robust ergonomic evaluation that was already implemented inside the software. Finally, we wanted also to verify if this optimized solution that we find out using the cost function was totally possible to be performed in a real scenario. So for that reason, we replicate this solution at the IT laboratory, and then we use the history of the robot joints that we obtained with IPS robotics to program the robot and then to perform the activity. We find out that it was totally possible to be performed in a real scenario. So as a conclusion, a new proposed methodology based on a cost function for hybrid workstation allows selecting the best workplace solution. Ergonomic constraints and comfort advantages must be contemporarily considered in the current industrial manual work. The use of IPS IMA combined with IPS robotics allows the analysis of hybrid workstation in the early stages of the design process, and ergonomic risk, anthropometric mismatches, and what-if scenarios can be evaluated with IPS IMA easily. Yeah, some reference, and thank you for your attention.
Yeah, questions for Manuela? Folks with an eye towards manufacturing here.
I have a question for the team and I guess the folks online as well. Are any of you familiar with IMA? Have you ever used IMA, the digital model? All of that. Are you aware that it existed?
And IPS, I'm aware of it. I haven't used.
Just curious.
I'll put a question to Manuela. This is kind of a tangent, but you were at the IPS conference in Germany last year or last month as well. One presentation that I did not touch on here because it was more perhaps IMA or robotics related was the presentation from the Technical University of Munich, where they were looking at using IPS robotics to do operations similar to what Manuela was doing, but to do plug-in connections on wire harnesses. And so they were looking, and as part of that, developing special grippers as well as connectors that would work for those type of scenarios. Did Manuela, since you're more steeped into this, did you get a chance to speak with the presenter from Munich, or do you have any thoughts on using this kind of cobot work for wire harnesses and cables?
No, I didn't have the possibility to talk with him, but actually, I mean, with another projects, we were also doing like the collaboration between IPS IMA and IPS cable. So it was quite interesting because we were trying to assemble like a high tension cable on the on the car. So it was actually similar as the picture, as the video that Anton was showing before, that the mannequin was performing this activity. So of course it was kind of challenge because we need to do some improvements, as Anton was saying, but it was actually possible. So with this project that I just presented, is totally possible to also perform this kind of simulations where we are also doing human-robot collaboration. And in that way, we can identify possible criticalities, how is going to be the interaction between the human and robot, and then perform like changes that improve the quality of the working place that we are designing.
So thank you for your input. Appreciate that. All right, and well, I guess I'm not seeing any more questions here or in the chat.
I have a question. I have a quick question
okay.
for Manuela. Yeah. So I do see that. I mean, it's pretty interesting to see that in IPS you are able to do the ergonomic simulations, whatever you have shown. So I think I haven't seen before that you can do this in IPS. But what I want to ask you is there. I mean, I think in Ford we have been using other softwares like the Jack. Not sure we're using now, and also process simulates. So just want to ask you that when you do ergonomic simulation in IPS, do you also get the force and the torso angle? What you use for the ergonomic analysis, like how much the operator is bending, So the torso angle, the force, and so many other parameters.
So like having the exact value right now is not possible to see. I mean, inside the software is calculating of all these angles, because at the end we are doing this kind of ergonomic evaluation. So right now you have Rule and Reva, and we already implemented EAWS. So we are finishing some things, but it's already implemented. And according with the force evaluation, we are also implemented that part. So we are implementing the force atlas. So like in the, I don't know, probably next year, you will also have the force evaluation inside of the IPS IMA. So you will be able to perform also this evaluation.
Thank you very much.
Sure.
Thanks for the question. Are any other questions from the audience here or in the cloud? Oh, yes, Mike.
Hey, Carl, can I recommend, I think we're a little off schedule, but can we take our break like right now until 3 o'clock and then pick up back again? I think we've got all the presentations from Europe, correct?
Right.
So I just see people leaving, so I just want to make sure we get like bio breaks for everybody at that workshop and then we can restart again. Sorry, is that true?
We're only like 3 minutes behind anyways. We want to take a.
Is that good?
Yeah.
Okay, thank you very much, Manuela.
Thank you.
Thank you.
Yeah.
Bye-bye.
Good night.
Good night.
Okay, so let's start again at 3 o'clock. Is that okay?
Yep, sure.
All right. Coffee back here, tea, cookies, what do you need?
Where'd they go?
Yeah, you're John. I know we've been on several calls together, but yeah, it's been changed.
It's in here.
Did you make it upstairs or did you find it early?
It's like, it's like a egg, I call it the sun girl.
Perfect. Go with Warren.
I'm gonna try to make it go on.
No worries. No worries, so. All right.
Let's see it.
Well, thank you. Thank you.
Yes.
I'm sorry, sad.
So you're gonna drops like two. Where we're going?
Yeah.
You must have this. She's
How is that stuff on retailers? What up in the show?
Yeah.
So I'm doing one thing, getting with my daughter, I'm happy. That's the point.
Your bullish on.
Yeah, I had no idea. And yeah, and it's folks, the other, known now for years.
I thought it was the strap. Oh, yes, I was.
Yes.
So that.
Right.
You didn't want to have that. There was a problem.
Well, I took out.
Sorry.
No. Right, great. That's something that.
That thing, you think that's the, just your.
That was actually one of the things that Bruce was trying to touch on, is that we're using the human tolerization for the model. So really, right now, is the more pushing. Whether that's a new solver, parts, whatever here. Wow, it's just like that. Stupid change sometimes. So I'm going to that's not. So this doctorate be some more. The second. He told us a little bit from Samsung. That's right. We can find a hearing artist. So I'm always. Doing like on two. Yeah, everything on it. See, it's like with the dying back. I'm still, because I never thought it was just the teacher. Always, it's sort of like true. But it sounds like there's been nobody noticed to do anything with space and now yeah, it's a share. That's right. Yourself, critics, city takes in, they're like, we there's some presentation, but I talked screen, after I gave out, she was running rice, this is all quiz too, right? Which you invented, okay, but there's a lot of contact, a lot of issues. Like generally using engineering workstations, I mean, talk to the folks at Flexi Tech, they're more closely connected with work logging with brake guys. Yes. So you're talking about brake hose or colorized sensor cables. Yes. Getting into your neck of the woods, bundles, that's the ones that I like to die harvest. Well, that's where you want to get with the BoardNet Century D, and that's really what is being done there, and that spawns out Flex Hub, which is something that we want to talk with you too. We have a database interface and be able to take in all that data. I talked to us. Still very comfortable. Oh my God! Yes. Single slide on it. So like integrating that. That's the thing about the next project too. Any feedback. Okay, for transparent. Okay. Well, yeah. Hey there, Janice.
Hi.
This is Alex.
So nice to meet you. Just wanted to check also if you still need your. Sure, next. Great. So Sure. Very good. Yeah, likewise. Thank you.
Yeah. I don't know, if you mentioned single sign on, what do you mean by?
So like everything that you have,
Mhm.
a lot of the main software, so be I log, or even I get it behind one log.
Okay.
So you have to be on our. Or you do that on where.
Okay. Okay.
This is one sign. You know, how ones get on board.
No, okay, great.
So well, like it's working.
Yeah. Well, Francis got
telling them like down the street. Well, I know it takes a few hours. I'm still short. And there's some like utilities to kind of bridge the gap.
Mhm.
There's just some other applications.
So it's at 6.
We're inside of 5.
Oh,
I think you're 5.
Yeah, I'm trying to.
That place.
Williams.
That's the place, it's the grocery store and the market, the restaurant.
Yeah. So Bill said,
It's a good eat, so
800 different kinds of all over company. It's like.
it's been a while since I've shot. I shot.
He did some of the magic to make it work, so I mean, definitely the last thing, saw somebody,
It's quite a little shopping, I go down this little stretch of.
organizing the sprayer and bringing start the classes and the cheap slots. Yeah. That flare all going and. Unfortunately. Yeah.
Who's the word as Paula?
Yeah, it's not.
I guess we like.
If someone else.
Solve
Yeah, gotcha.
but I can get it. Called over there. It's scourgings.
But, and I mean, cool. Thing is, connected regularly, sure, like, send the spreadsheet.
I've been on a truffle oil for a long time.
Yeah.
We even get together with it.
I want to make it stop on.
So that's
Right across the street.
That's a.
It's later the 8 miles, 29. Scott up on
So.
Yeah.
They have a pretty,
Yes,
full selection of stuff.
See, that's on the line was there when I was working.
No, it's pretty, it was about a year and a half and stuff like that. I did stop there, after 1 year. That's why I was not,
Oh, okay.
I'm like, since I have a couple of minutes, right, driving almost right by it.
Pull all the characteristics from that I'm going to use with P.
Yeah.
To do the simulation.
I don't know pretty much. I enjoy this drive shop.
So if there's a,
You only have to-
wish list to restock a winter kit, then that's a good place to do.
Makes a call. Let's not there, right? Because I might go by there. Gosh, this hop slang supposed to be released today.
Right, they,
So, but that's using different solver. So that'll have, yeah, right. So, the point is, work that's triggered that Anton talked about is really going to affect cable first. So you're
So what?
yeah, so whatever.
Is that the version that might call out?
Yeah, check it out. Yeah, I think there's one that's, I think it's. Feels like I'll send you both some. The cloud contracts, it's always from that,
press build on it's a programmer. I think so. Telling them to zero. The folks get programs from and say, oh, right. So we've reached that task. That things. What's it's like, yeah, every the results are checking the actual spray. You flash your metal work, you fix down, because those are going to be the same height, but what? We're going to like check on size helping or several springs inside of the door and bringing on. Instead of general attention over there, because it's not attention for spray. It's not more to still there's like bring a simulation like this. There's like that's first thing this new thing forms there and they try to figure that it's one thing you show it now on virtual feet. Show you that through this feet. A lot of do that. I think there's like sugar all over.
Yes, now we're going through the efficient thing and then.
Okay, we just go in there to like right now it's giving us a lot more intense whatever you all you get to that was also that house member. Well, they're committed to this. Yeah, we're getting rid of a lot. It's a goal. So it's about to get at least apply it. And there's all we put a prototype on. Whatever you do to increase the scale. Hold on. I'm going to skills. And yes, you can. Charles, says, clear eyes. So the IPS version of the Death Star.
What's that? This?
The
Background.
the background.
Oh, I don't know. I think it was King of his PC.
Woman laptop.
Yes.
Cafe.
Yeah. Oh, yeah. I think
We're getting
you
into
want to
the-
just left it over.
We're getting to the meat.
Yeah. So yeah, no. You? Yeah.
I gotta, I'm gonna get home. Yeah, I know. Okay.
We're going. I was going to, I gotta go, I gotta. My dog is gonna kick off at me. He's like. Remember, he's in the line. He's supposed to. Well, you know what? Oh, yeah, no, that's chaos. It's not. I understand. Super jealous. Finish the process. Yes. Sounds right on this also. That's it's not. I don't know. One reason for not. Down getting long. Like, oh, I like village a little. Yeah, I can't. It's also. All right. Great, show you know.
We're only a few minutes. We're not doing too bad. All right. Everybody feeling refreshed? Right?
Head flowing back to the head.
Where's the describe
So you just want. But I can work IPS.
Yes, that's the one over.
Okay, so for the next few minutes, just want to take some time taking everyone through some features of the software that you may not be aware of. Many of you I know actually already have access to some of these features. So just wanted to kind of do some deep dives into some of these other things. I guess tips and tricks sort of for some of it. But I want to talk through the cable optimizer because I know we saw a lot of interest. Yes, it's recording. It should still be.
I see the button up.
Yes.
Okay.
Okay, thank you. I appreciate that. Yeah, so we want to go through the cable optimizer. I also want to take everyone through how we can set up clips and connectors in IPS, talk a little bit about durability and dynamics, and then lastly, just something I found interesting with some of the people that we're working with hydraulic hoses that we saw at the IPS conference in Germany. So to begin, we can go through a couple of examples with the cable optimizer. So the cable, it's a tool that will allow you to put in some design requirements, put in some variables, tell it how you want it to optimize your design, and it will attempt to find a solution for you. So we can do this with or without a motion associated. So we'll take a look at examples of this cable, running along this engine bay here that we've routed, and you can see that there's actually a crash condition between the cable and some of this metal here, right? There's a hole that our cable is designed to pass through, but we're crashing, right? So obviously I could come in here and I could change the length in this segment of the cable. I could take some of my clips and maybe, play around with reorienting them or changing their positions, all the kind of manual work that we normally do to optimize flexibles in IPS. Or we could just give it a try with the cable optimizer and see how it works. So to use it, you'll just select the flexibles that you're interested in, hit the flexible drop down, and go to the cable optimizer tool. And then it's gonna ask us for some constraints and then some variables. So first of all, what is our preference here? We could set the algorithm to look for a solution with either a shorter length or more clearance. Often I'll just kind of put that in the middle unless I have a reason not to. And then we need to define some constraints for our flexible here. So I'm going to take a look at the bending radius, and I'm also going to create a value measure of the clearance between my cable and basically everything in the edge. I don't want any collisions. We're going to see obviously it's colliding, so we're going to see that value will be 0. So I'll add that into my constraints here as well. And then in this case, let's say we want the bending radius above 40 millimeters. On the right side of the screen, or the dialog box, rather, we can see where we can add an emotion, and then we can also see our variable objects. So right now, my variable object is just my cable. I can also tell it to only change the length in certain sub-segments of the flexible over here. So you can check or uncheck these boxes as needed. But the other thing I can play around with in this design is potentially the position or orientation of some of these clips. So you can add these into the dialog as well as variables. And then we have some options here for, we can tell the software how we want it to change these fixations in order to find this optimized design. So by default, they're fixed. We can allow them to freely rotate, which is basically just about their z-axis, or just freely twist in all directions. Or I can check this custom box down here and define some custom parameterization. So in this case, I want to allow this to rotate about its z-axis, right, which is basically up. And then I also want to allow it to translate a little bit in the XY plane we can see here. So I'll go to those custom settings, and I'm just going to say constrained, and I'll allow them to move plus or minus 10 millimeters, let's say. And then I'm going to allow it to freely rotate about that z-axis. And then I'll do this as well for my other clip. Okay, and now I've set up the optimization problem for the software. And I can just click run and see how it goes. So we can see it's trying to search for feasibility, and then it's trying to find a solution to this optimization problem that we've set up. These can take anywhere from, 30 seconds to several minutes to, if you have a really complex problem with a lot of variables, it can take some time, but I mean, in that case, you kind of just leave it alone, set it and forget it, and see if it's able to find you something. So while this one's searching, I just want to talk through how we can also set these up for IPS models with a motion as well. So in this case, we've got a coolant tube here. We have a motion for our engine. And we can also add this motion into our optimization problem as well. So again, the things here we could really change. We could change the length of this hose. I could also try playing around with the orientation of this rigid pipe that's coming out of the radiator. Or again, I could just go to flexible dropdown, select that optimizer option. And this one, I'm going to leave it to short length. I will create a measurement again for my bending radius. I'm going to add that in here as a constraint. And let's say in this case, we want it above 30 millimeters. If I open the other side of the dialog, I can add in the motion. And then lastly, just my variable objects, in this case, radiator hose as well. So let me drag that in. And then again, you just got to look at the axis for whatever particular item you're interested in. For this one, it'd be rotation about the Z axis. So again, I'll just come in here, go to custom, and I'm just going to say that it can freely rotate about Z. Okay. Hit run. Start trying to search for us, and we'll see how long it takes to find some kind of solution. So I guess while we wait for these couple models to run, are you familiar with this tool at all? You ever used it? Okay. Any success? No. No. Cards. Was that? Do you think it was just due to like too many variables or too complex of a problem?
Complex.
Okay, sure.
If it's a simple problem, I can fix it myself.
Sure.
But you get into some elaborate complexities and you've got deflecting and bullshit and all that. I never came to
Sure.
a
Okay.
reasonable amount of time.
Yeah.
And it would take it outside of the tolerances I needed to be.
Gotcha. Okay.
There's one of the problems has been that I have a design, analyzing a design that somebody else did.
Right.
I can't move their retention.
Right.
You know,
Yes.
I have to go with what retention, like say, have, I can make suggestions and stuff, but
Right.
then it's, but at that point, they don't want to hear you,
Yes. Yeah. Yeah. Where we've had some success with this on some of the consulting projects we've done, where we're given a design and we're given, some things we can potentially change. And for me, it can be a good first pass, or a good way to at least just kind of say, yeah, let me throw this at the wall and see what sticks. Maybe it'll find me a solution, maybe it won't, or maybe it will get closer to like ultimately where I want to be. So just kind of an interesting tool.
I'm sorry, real quick question. So the first simulation where you were setting degrees of freedom.
Yep.
For the clips that's shown in that simulation, could those degrees of freedom be contained within the clips that are within the database by doing that? Or do you have to you're doing this with each simulation? So these clips come in with no rotation.
Correct.
You're going in there and saying plus or minus 10 for this simulation, but once you go to a new study, you bring the same clip in, you have to reset the parameters of plus or minus 10.
So or translation within some constraint value, right? So I could create and actually we'll see when we talk about clips and connectors, I can create a clip that will rotate and I could give it some range of motion in that rotation. For this particular optimization problem, I'm saying take the entire clip and you can rotate it freely. So yeah, if we set it up in the database with that kinematic built in, it would account for that. But in this case, yeah, it's just a static clip, and I'm saying, well, see if you can change its orientation or translate it in X, Y, and find something that's a better solution.
Bruce, to your question, we do also have fleXstructures has a partnership with the company Noasis. You might have heard of them. They developed optimizing technology. What I believe what we're looking at is a version or flavor of Noasis, but that collaboration continues, and that's something that is highly sought after. So if you do have a real world problem that is found unsolvable in some way, perhaps that's something we could revisit together with Sandalwood to look at that and provide feedback to our development team as well as Noasis. That might be interesting. Yeah, we do have Anton on the line. I don't know if I can put him on the spot. There is a question here from the chat. Did you create your cables in IPS or did you start with native CAD?
These were created directly in IPS, but for the the cable optimizer, it would not be important that you can certainly make them for pre-existing CAD geometry. There's really no difference as far as the software is concerned. So for the it gives us this little summary down here in the bottom, and it tells us what it changed and how long it took. So for this motion problem, it took 43 seconds, and it just basically all it wanted to change was the length of that segment. So even though I said, okay, go ahead, you could rotate that rigid tube if you want to, it was like, no, we don't need to, we can just change the length. So fairly simple, optimization problem, but kind of nice to just tell it to do it, see what it comes up with. And then this one, I don't know. I guess we'll see how long it takes to find a solution. And I think we could probably come back to this. So we'll just leave it alone and see what it's able to find. Any questions on the cable optimizer before we move on to clips and connectors? Yes.
And this could be in the tool because I probably haven't played with it enough, but so there's two separate things. There's tolerance envelope and motion volumes. So you could put a tolerance envelope on that static now segment and create a tolerance envelope. And you could also create a motion volume to show it going through space. Is the ability to be able to combine the two into one in the tool now?
Absolutely, yeah. So if you go to the flexible drop-down tolerance envelope, you'll see here that you can add in a featured motion. And then, you will account for, let's say I allow the length to vary plus or minus 10 millimeters with that motion. And we can see what it looks like. Where also, obviously we can exclude the motion. So just change the color of this and the transparency a bit. Right, if I just do it, no motion, it's just going to be, a much smaller volume. So you can do either or, you can do both together.
Before you move on, John, there are a couple of questions from our remote attendees. The question was, how do you analyze the stress in hoses tables? And I guess the question might be is whether you use that in optimization.
So any of the value measures that are available as part of the cable optimizer package. So if I open that up again, we can add in any of these value measures on our flexible and add them as a constraint into the optimization problem. So as far as stresses, we can look at von Mises stress, normal stress, or shear stress, different moments, forces. Basically whatever is available in the basic cable tool is also available in the optimization tool.
Okay, great. And another question came in. Have you used sleeves over hoses in the cooling lines?
We've done some work with those. Typically, either in IPS, we're always looking at the flexible as from a macroscopic view, right? Like we're not concerned with what's happening microscopically in different layers of a hose or something like that. So we try to define the material properties for the entirety of the segment. So you could either, if you're talking about, let's say a hose where there's a particular part that's shielded or has a different diameter or different stiffnesses, we can model those as separate flexibles and then just link them together with nodes. And that's modeled at Brilliant for us. Oh, he's still thinking. Okay. Interesting. Okay. Any other questions on the optimization? Okay, cool.
One question on maybe not on the optimization, but on what are the analysis? I mean, or what are the visualization you normally check? I mean, I see in the bottom right you have got the bend radius alone, but how do you analyze the stress on these hoses, or what are the parameters you look for? Yeah.
So I mean, it really depends on the user and their design requirements. But again, we can, provided that we have accurate material properties, we can look at stresses or forces or moments or basically anything in this list that is of interest can be directly measured and tracked in real time as we're doing the simulation.
Yeah, I mean, do you have a real definition of all these things? Because let's say I want to see how much force the operator needs to put while making that joint connection. So shall I go for a total force? Shall I go for a tension force? Shall I go for a shear force or an external force? I mean, do you have real definitions of when to use what?
You're talking about for assembly?
Yeah, from assembly, yeah.
Owen? Not really, right? I mean, it depends on the posture, it depends on the repetition.
Yeah, there's a lot more ergonomics side of that.
Yeah, and we're also, I should say that we've been working with US Car to try to help develop, some of those standards. So yeah, the issue of manufacturing feasibility with force is that's a very complex problem. But no, I wouldn't say that there's a catch-all standard for that.
Yeah. Okay. I mean, yeah. I mean, why ask? Because whenever I do some assessments or analysis, I do see a lot of forces, and it's very confusing that which one to select. So yeah.
Let's see here. Okay. Well, I guess we'll see if it finds it or not. But in the meantime, yes,
You're looking for, you can have the material property be variable. It's like, maybe we could harness the shapes to cover it as something more flexible or not.
Sure. So you could certainly, right? So if I create a flexible with effective parameters, right? I can just go into edit.
So you
change if you wanted to look at the forces, yes. If we wanted to understand the shape or the motion of the flexible, we can use the tolerance envelope to do that. But yeah, I think if we were trying to calculate force, I don't think there's a way to color code the color map. Yes, yeah. So you could certainly create a visualization, right? A color map of tension force, right? But it's not going to you wouldn't account for variation in the material properties, right? It's just one property for whatever flexible you model. Yeah, that's an interesting question.
Yeah. Yep. Maybe, I mean, if you have something on the force, I mean, I'd also like to understand if you take that up and have a look. Yeah.
Okay, sure.
Thank you.
This is the wrong one. So I wanted to touch on clips and connectors in the IPS tool. So obviously, often we see users kind of just modeling the flexibles between clip geometries that came in with this, whatever model you imported for your CAD or PLM system. But we can also define any kind of clips and connectors in IPS, add them into a database, and then your IPS software references that database every time you open it, right? So then you can just continuously use these clips and connectors over and over again. I don't know how short we are on time here, Carl. I was gonna show how to create one. It only takes a few minutes. But I guess, you know, just as kind of a use case, right? So in this case, we've got this, got a brake line, we've got a wheel speed sensor. And if I play through this motion, we can see that there's definitely a collision here between a wheel speed sensor cable and the vehicle. So one thing, you know, you could do to try to fix this, obviously we can play with the, you know, the length or the routing, try to eliminate this contact in some way. But we could also attempt to, you know, use some kind of clip or additional fixation point here. These are defined in the cable clip browser. So if you go in there, it does come, the software comes with a really small library of potential clips and connectors. But we can define these also for ourselves quite easily. So if I want to make a new clip, first of all, I just got to bring in some CAD geometry. And this kind of, John, goes back to what you were asking about, you know, those prismatic clips, right? So in this case, we've got an upper portion and a lower portion. And this upper portion is going to be able to rotate about that base there. So if I want to create a new clip, and it's very easy if we don't have any kinematics to add, we can just open up that cable clip browser and just say create new. And then we'll open up this clip wizard dialog. And it really walks you through it in a very straightforward way. So first of all, it wants to know, you know, what are the geometries that are part of this clip? So for this one, we've got a base and an upper portion. Then we just hit next. We need to define a base frame. So basically, the clips will always be attached to nodes in the IPS tool. So at what frame is this clip going to attach to the frame on the node? So for this one, you know, I would assume that would just be on the base of it. So we can just align this base frame to the base here. Once that's done, we can create links. So if, you know, again, if we didn't have a kinematic, basically we just have one link, but in this case, we're going to need two. And you can see it building up the kinematic tree here on the left side of the screen in the scene tree. So since I want this upper joint to rotate about the lower joint, we just got to link them together in a tree so that this upper piece that's highlighted orange right now is dependent on the position of the base link. And then if I want this to move properly, I've just got to relocate this joint so that it's on the correct center line for this upper portion, right? Because I want it to move about this central axis. So I'll just pick a circle here, hit OK. And then I'll just add this back into here. Next, I've got to define some joint properties. So there's a lot of options here. But if I right click, I can see this constraints here. So by default, they're all going to be fixed, right? They don't move at all, but we can create prismatic or revolute joints. You can also define a stiffness value here. So basically how much force will it apply per amount of motion. So you can define a stiffness value for either the prismatic or revolute joints. But in this case, I'll just say revolute about Z. And I can hit this button here to test the mechanism. You can see that it's rotating here. And then lastly, I just need to add in what's called a director frame. So it's how do we want our flexibles to actually attach into this thing? So if I just hit add director frame, I want it to be linked together with this top piece of geometry. I can align it to this circle here. Oops. And this is where my flexible is actually going to attach into the clip. And you can see this kind of preview with the arrow, right? Obviously, I want my cable running through it. And then one more thing, we have some more options with how the cable actually mounts into this clip. So these can get, you know, as complex or as simple as you want. So is it totally fix the cable when it's in there? Is it able to freely translate through the clip, or can it rotate in any way that it would like? Is it clamped longitudinally? And then we can define a support range. So in this case, I think this thing is like 10 millimeters long. Yeah, so you can see that preview updated showing me how much of the cable it's actually going to clip. And then one last thing that's kind of interesting is if it's a clip that could accept any size of flexible, we can hit this button here for offset bundle, and it will automatically, when you connect the flexible to the clip, it's going to adjust based on its diameter. So again, yeah, there's a lot of options here. And then at the end, you've just got to, put in a unique identifier, name, and a type. And unique identifier. Okay, that's why. Hit validate. You can test the mechanism, make sure it's working. So it's a very, very handy tool. And then if I just hit finish, it will be available in my database. So going back to it's going to want me to restart if I do that. So I'm not going to do that. So going back to our speed sensor example, once we've added a clip into the database, we just keep using it over and over again. So they're commonly used clips. You can define them, and then to attach them into your sim, you just need a node, and you can go to this insert clip option here. And then if you click on the 3 dots, that's going to pull in your database. You can see little previews of each of the clips that you have. And I can just hit insert here. Do that. Sec. Well, database. Insert. All right, I don't know why it's doing this. One moment. This guy. There we go. Okay, now if I hit apply, we've added this clip in here. And then to link it to our cable geometry, we just got to add in another grip point. So I just kind of drag this grip to approximately this clip, hit insert. And because we've defined everything for this this clip, it's going to automatically align it. And if I play through that motion, we would see that kinematic behavior of this particular clip rotating as we go through the motion. So kind of a long-winded demo, but hopefully it gives you an idea of how you can set some of these components up. If you're commonly using them across many different IPS models, it can be really helpful to just create them and be able to add them in whenever you may need a particular clip or connector. So any questions on?
Yeah, one more question. Like when you are doing this simulation of this motion, to do analysis, you would need the material properties of these flexibles, right? So
Yes and no. It depends on what you're interested in. If you're interested in the shape of the flexible, the material properties are much less important. I mean, they do have some effect, but often you can get a really good approximation of the shape of a flexible using just generic material properties. If you want a very highly accurate result, then yes, you need some kind of material property to define for it. But I mean, this one's probably just defined with the generic properties that default in. When you create a cable. And
yeah,
I guess
it's by default, right? It's by default properties.
correct. And of course you can edit them, but what I would say is we did a consulting project for one of the electric vehicle manufacturers. And what we did all of the modeling, right? Because you can edit the flexibles while the testing is ongoing, right? So we created the model. And then when we got the material properties back, they said, okay, go ahead and put these in there. And we were on a call with them live, and I input the new material properties and I hit play. And they said, I don't think it updated because it looks exactly the same. So I copied it, and then I input the material properties. So I had them kind of overlaid so we could see them both. And the shape was almost the same. But then, of course, when you calculate forces on like the connector ends or something like that, then we see a change there. So it just depends on what you're interested in and what level of accuracy you need.
Thank you.
Yeah. And then lastly, I just wanted to talk a bit about some of the durability and dynamics capabilities in IPS. First of all, for any flexible that we've created, we can do what's called load data analysis. So for a particular routing, length, etc., we can just right click on the flexible and hit this perform load data analysis button. And that's going to create this value that we call pseudo damage. So it's a unitless measure of the risk of damage. It's not the same as some of the stuff Carl was talking about earlier with absolute life prediction. But what it does do is it gives you a really good idea of where damage is likely to occur on your flexible. So in this case, we can see based on the color map, right? I mean, this is what we would expect. Where our flexible is going to a rigid fitting, it's probably where you would most likely expect some damage to occur. And then if we change anything about this design, so for instance, I can just go here and change the length, and I'll make it a bit longer. And if I rerun this load data analysis, it gives me a different value, basically a pseudo damage value, a risk of damage. And what these are great for is just comparisons between design alternatives. So again, these values don't tell you number of cycles to failure or anything like that. But what this does tell us very clearly is that having the cable longer, in this case, significantly reduce the risk of damage. So it can be really, really useful if you do have a bit of flexibility in your design and you want to see what the effects of certain changes may be on the durability of routing. This is really great. You use this very extensively. Then lastly, just delete these out of here. I wanted to just do a very quick demo of the dynamics capabilities in IPS. So in IPS cable simulation, by default, everything that we do is quasi-static simulation, right? So we're basically stepping from position to position, but we're not considering damping or inertial effects when we do this quasi-static simulation. And oftentimes, if there aren't like very large accelerations or excitations in the flexible, it can be certainly a sufficient enough simulation to get you to an optimized design. But if we do want to take a look at some of the dynamic behavior of these flexibles, we certainly can. So to do this, we just create the cable as normal, do our quasi-static simulation, try to optimize the design as much as we can. And then from here, we can, from that existing cable, create what's called a dynamic rod. And then it asks for some parameters here. So we can either just put in a damping ratio. So basically, how quickly do we want it to move back to its equilibrium position? And then also, I haven't done much work with this, but there's a damping an effective parameter that we can use, and I believe there's a way to test for that. But I haven't been directly involved in that work. But I think this is kind of interesting. So if I just create it with a the standard ratio of 1, and then now let me change the color of this so we can see. So I'll make the dynamic one is going to be blue, and the quasi-static cable is going to be gray. And now if I run this dynamic simulation and play through this motion, and we'll see the difference in behavior between the two. So you can see again, the dynamic one is in blue, quasi-static is in gray. So it can be an interesting way, even if you don't have that effective damping parameter, can give you a really good idea of just what the effects of dynamics could be for your designs.
Have any of y'all worked with this module? Is it something that comes into play? I imagine not very often, but does it come up?
I've seen a license, I've not used it.
Okay.
I think the durability analysis is really very helpful. And this can certainly be useful depending on what kind of analysis you're doing and what the components are. Any questions?
Did you want to ask that unwrap thing now or later?
Whenever it feels right, I'm gonna interject with flow.
Yeah.
Okay, sure. I think, to be honest, I think I'm gonna have to check into that a little bit. Okay, so,
That's fine.
but I'll certainly look into it and get
I'll
back to
shoot
you.
you an email explaining the steps that we use to do it.
Okay,
Make it clear for you.
yeah,
Attending to do it,
yeah,
how we're attempting to do it.
okay, yeah, that would be great. How we doing on times here, Carl?
Looking pretty good, 3:42. So, and you've covered the modules. And I think
It did, yeah. It found a solution. It took 15 minutes, which is kind of surprising, but you can see, yeah, it eliminated that contact. I've got a bending radius of 48. Minimum clearance of almost 7 millimeters. So, yeah, kind of interesting. I closed the report, unfortunately.
When you're interpreting that solution, should you assume that now those clips are fixed into the new position or that there's?
Yeah, so I just closed it. I X'd out before I got a chance to look at it, but it gives you a report when it completes the optimization that you can then save off, but it will tell you, we changed the orientation of this node 12 degrees and we translated it 10 degrees in the x-axis. So it does outline the changes for you.
But it's not like the cable is now the perfect length where those things are still able to move, but it's in the right position. We just fix the positions to make it.
Correct. Yes. Yeah. So all we put in was, as the constraints was just our bending radius above 40 and make the clearance above 0. And what's interesting too is that it will find you, if I reran this, it would probably find me a different solution and it would probably find it in a different amount of time, right? Because it depends on how the optimization algorithm goes through, but it's, if you're looking for, quick check or just, hey, let me see if this works, it's kind of nice to just kind of leave it alone and see what it'll come up with. Right.
thanks a lot, John.
Yeah, thank you.
If you want to hit a question, Chaz there.
Sure.
Getting that from a couple of other folks. The question was, how do these analyses compare to CAE tools? That's a question that I can take back to our folks at development and headquarters, because I believe we've done some correlation between INSYS, NASTRAN, Atticus types to see how our stresses compare with that. So it'll be a homework assignment. All right, were we on to the next item was the VR?
Yeah, let's do it. How are you doing over there, Scott?
I'm all over.
Okay. Yeah, I'll yes, I will. Yeah, if you want to treat your computer, I mean, leave you plugged in there. I'm not. Or do we want to? I think we do want to switch this.
There we go.
Either way. Okay.
Yeah, might steal your power work.
There we go. I knew I definitely just violated the minimum bend radius of this USB cable. I should have simulated it with Emma to make sure I would have enough fingerprints, It's okay. The one other thing we wanted to talk about here is IPS VR, which is fairly new module. It's been out for a year and a half, maybe something like that. So let me share this screen. So could definitely be an interesting tool for taking a look at I mean a number of things, right? So at a very basic level, it can be cool to if you have a new layout or workstation or product or routing or whatever, you can very easily just kind of jump in a headset and even just visually taking a look at stuff. But we can also take a look at assembly feasibility, interact with flexible components in the VR space. And what's nice about it is it just runs off of Steam VR, which is a very common VR platform. So for stuff today, we're using an Oculus Quest 2, which is like a couple $100. So it's not a fancy VR setup. You don't need a VR lab. You don't need base stations, nothing like that. But it will work with any Steam VR compatible headset. So let me pull up your VR view. All right, you're just kind of waiting in the lobby there. And then basically to use it, all you have to do is connect your headset to your PC, fire up Steam VR, fire up IPS, and then it's a one-button connection between IPS and IPS VR. So with just a click of a button here, we've got Scott into the scene. It's like you're lagging a little bit. I don't think we have a very good internet connection.
Nice and slow, nice and slow.
You can do it with or without a cord. So we can see Scott's VR view on the left side and just the IPS scene here. I'm sorry, other way. The IPS scene on the left side, Scott's VR view on the right side. And what we're doing here is we're using it's called dual mode, right? So I can make changes to the IPS scene, and Scott will see those in real time. So yeah. And oftentimes too, we'll do some of this stuff. I actually live just outside of Denver, Colorado. Scott is located here in the Detroit area. So I will remote access his PC, and then he can be in the headset, and I can move things from 1,000 miles away and have it auto update. So it's pretty cool. So again, just gives you a good immersive kind of feel for your products, your processes, your workstation. So Scott, as an example, we've just got a basic demo here of this seat assembly line. So we've got a component here in orange in the dunnage that we've got to install on the seat. So Scott, if you want to just pull that out of there.
I mentioned that we have a wiring turned on here, so if I try to pass it through the front, I can take it out. I can grab it with both hands, and I can reach over and install it.
We can also, we could, if we want to, I guess let's record a motion. So we can also record some of these things for review.
So it's something you do from the desktop or from here. Just record motion. And it's not recording until the scene is not move in the scene here. And I can install it. You'll need a couple of friction points where I grabbed it, and then it's down here. And stop motion.
Just delete those. And it's a little bit choppy, but we can smooth it. Yeah, I think you're right. Which is where it's nice to have a strong internet connection. But then we can play that back and kind of just take a look at whatever tasks we're interested in, which is an example. You can see it kind of moving through space there, and he can also view it as he's in VR. One of the things I find really interesting and kind of most unique, there's a lot of VR systems out there, but we can do some work with Emma in the VR environment as well. Trying to get rid of these hands that we added. A sec. That is the motion, yes. Yeah, so here I can play that one more time. The only thing it doesn't love you doing is deleting stuff while he's in the environment. Yeah, so you can see it going along there. Oh man, okay. That's not very happy with us, Scott. Yeah, it's a little bit late today. Yeah, okay. Well, better Wi-Fi next time. Yeah, the interaction between IMA and IPS VR I think is really interesting. So we could do a couple of things. First of all, you know, for Scott, he can reach this no problem. Of course, we could bring in a mannequin and just kind of posture them and see what the reach would be like. But we can also posture them using VR. So Scott, if you want to reach up there and just leave a grip point on that piece you're trying to grab.
That's just the number one. One button. That'll be the grip point up there.
So we can come back and create a mannequin. Let's say I'll maximize this for a minute. We can create, for instance, a much shorter operator, right? So we can make a 5th percentile female. There we go. Okay, she did. All right. Here. And then basically the way IMA works in IPS is we position these grip points, and then we can just tell her to try to reach this position. So based on that grip that he just created in VR, we can just drag and drop it onto her, and it will show us, you know, if she's able to reach that position or not. And then of course from there, you know, we can make some adjustments, experiment with, let's say, moving this thing up or down, right? So I could try, let's move it down 100 millimeters in Z. Or not, I don't know. Hang on. There we go. Okay. There we go. And I didn't. Okay. I didn't turn on her posture or collision avoidance, but she'll basically try to maintain that position. So you can just experiment with different postures, and yeah, kind of interesting. One other thing we can do is we can actually do motion capture with just that Oculus headset. So I can basically attach a mannequin to Scott, and they'll follow his motions as he goes through some set of tasks, which can be really nice because one of the limitations of VR is you have no sense of your body, right? As you're in there, you're just kind of in a headset. You can't feel what it's like. So now I've got Scott attached to this guy. So Scott, if you look down, you should see your. So yeah, for instance, if you want to try to grab that part and put it back on the seat. Yeah.
We'll grab it there, grab it with both hands. And then we'll reach over the conveyor here.
So you can see, right? Like, so Scott, you were crashing there, right, with the conveyor. So see if you can reach out and not collide. Yeah, see, so you can get a good sense of based on, because you have this, you know, this mannequin attached to you, it can give you a good sense of spatial awareness for your body. So just yeah, kind of an interesting use case there. And then last thing I guess we'll talk through here is, Scott, if you want to jump over and take a look at the cable. So you can also interact with flexibles or connectors in the VR environment. So for instance, we have a cable here that's attached to a connector. So Scott, if you want to grab that.
So I can
was looking at the house, they said here, we're going to configure. And by moving around, we can see the cable update at the time. If I try to run it into the steam grill, it won't pass through. So and if I try to overstretch it, it's going to flare out.
Yeah, so any visualizations you've set up would be maintained in the VR environment as well. So
Quick questions or any tactile feedback for things like that, overstretching,
there is not. We've seen some development with haptic feedback gloves where like if I go to grab this, if this was in my 3D in my VR space and I go to grab it, the glove actually restricts your fingers from moving. But you don't get any kind of
generate massive force.
yeah, right, unfortunately. Unfortunately. Okay, so that's a very interesting question. So one of the updates Anton gave in his presentation, that's coming to the next release. So currently, to interact with Flexible, you have to create, either it has to be attached to a rigid body, like our connector here, or it has to have a node, right? We have to have a node and a grip point. But basically, what's coming next in, I think it's December, actually, it's really soon, is if you just try to grab the cable in the VR environment, it will by default automatically create a grip and a node there, so you can manipulate it at that point. Sure.
One question, like the layout that you're.
Just a moment.
Yeah, okay. Maybe I'll type in the chat.
Yes. Yes. Mm-hmm. Yeah. Yeah. So for instance, you could, it's not going to prevent you from moving it too far, but you could create a visualization on the Flexible for, let's say, elongation and set your max elongation to like 1% or something. And then, see if you're able to manipulate it around. But yeah. And it is fairly easy to set up. If you've used an Oculus and you use IPS, it's basically, you hit the one button, it'll come in. So.
We just have the question.
Yes.
Yeah, so I was asking like the layout that you're showing.
Yep.
This layout, have you created in IPS or you have exported it from some other tool?
We exported this from, I can't remember where, but yeah, somewhere else. It's just JT data in this case.
It's JT data, right? Okay, got it.
But yeah. any IPS supported format would work, right? So as long as you can import it into the IPS scene, all of the functionality is really the same as the non-VR. So.
Got it. Yeah. Thank you.
Thank you for your question, Dave.
Yeah.
And Anton, he's back online and said you are correct, John. Released IPS 2024 R1.
Okay, great. Yeah. And apologies for all the lag. That was this. Yeah. It's, you can see the performance bar based on your internet speed, and it's not supposed to be red like that. So this was not our finest demo IPS VR, but we're working with what we have here. So yes, like public Wi-Fi networks, that's for sure.
Another feature that's being developed now. One of the next releases that's only one person at a time can actually be active in a VR session. So John can support on the desktop when it's got in it, and we've had customer feedback from folks using IPS schema that they'd like to have multiple people two guys picking up with a. One, okay, a couple of things there. We are working to get more biomechanics into INMA, so that's coming. You would need to do that with the INMA. So you would go through the action the way Scott did, plot say an INMA match and on it, and then do the analysis back. So what are the things covered by Reba?
Compression and things like that, that is often looked at. There's nothing currently in those that become in the future. I think something like that.
Great.
All right. Yep. All right. Cool. So for bellows and grommets, another module within our software here, we can see as an example, we've got this bellow here, goes between the airbox, air intake here, and kind of the intake that would hold to the engine. So in here, set this all up. First thing we'll do is I will import the motion here. We're also going to take a look at that by import motion. We've got that there. And I'll add all our components that are going to bolt to the engine here and move with it. I'll add those to a geometry group. So I just need to create a geometry group. And I can drag those pieces of geometry into there. I'll call it engine components. And from there, I can make a rigid body from this. So this rigid body, we can then attach to the motion. And I'll show if we play through the motion. I need to slow it down a bit here. But if we play through, we can see that's our engine shake there. So now if we want to take a look at getting this all attached to our bellows here, I can come in here and I'll go to the flexible menu and hit the bellow finder. I'll also hide our other geometry to get started here so we can see everything we're working with. So we start with our bellow loaded in from whatever CAD system we created this in. And the first thing we're going to have to do is show the software here where the center line is. So it'll walk you through the steps here. But step one, finding the center line, we need to tell it where to start and where to end. So I'll place a start cap on one face here. Then we just want to drag that over the opening so it's kind of over the center. And likewise, for the end cap, I'll pick the other end here. So now if I hit generate center line, software will go from our start and our end cap there, and it'll look at the geometry around to find an approximate center line there. You can also add an offset from the ends of your caps there if you'd like. And that looks good to me, so I'll hit continue. And next you'll specify your mesh resolution that it will take here. There's a few different ways you can do it. You can specify manually what resolution you want, nominal and angular. You can also use this auto function, which typically does a little bit higher detail than just the default that's in the specify mesh there. So now we can see all our triangles are there on the surface, and you can see it follow up over the bellows there. Our third option that we have, it's an optional third step here. We can use the adaptive meshing. And we have a few different settings we can set here for minimum sizes for triangles, anything like that. And if I hit generate mesh,
we can see here with the adaptive meshing on the wider, flatter areas, we have much larger triangles now. But in the areas where we have more complex geometry to capture, we still have those smaller triangles to do so. And this can just help with some cycle time by decreasing your mesh resolution over in the less complex areas. You know, things run faster if you need to. And the last thing here to get our bellows set up is to set up the boundary conditions. And there's a couple different ways we can do that. First one here, add a constrained range. It gives us our sliders here, and we can use these little sliders or type in a value to create a range on the bellow there. So I'll use that there. And you can also drag it over to the other end by doing so. But I'll add our constraint over here. And another way we can do that is just with a lasso select. So I'll kind of line it up there. And now with this button, add by selection. I can just hold Shift, do a lasso there, and select all those points in the mesh. Now I've got my two boundary conditions on either side of the bellow there. I can hit OK. And then last thing here in the bellow finder, just hit Create Bellows. And this will pop up with our shell editor here, this is where we put in our material properties. By default, it's going to be kind of a semi-hard plastic here. And I'll just leave it at the default for today. But here we also check when we're creating the bellow, whether we want to have contact handling enabled. I'll say yes. We'll get to that in a few minutes here. And I'll also check the box to make it interactive. If we don't check this box, and we run all our simulations, it'll still put out the same values and everything. But if we check the interactive box, it'll do it visually as well. So when we play through the animation, we can see it move. So I hit OK. And you can see we've had a change there. I'll close out of the bellow finder. And I'll hide our original geometry here. So right here, this is the bellow we've generated. And you can see it does look a little bit different. That's because this is a middle surface, we call it. So we have the shell over here now in our object tree. And the shell, what that's doing is it's across the mesh, it's kind of finding the average thickness, and it'll go right in the center of that. So we can also change the visualization on that. By default, like I said, it's this middle surface. We can also do the same surface with the thickness of that material added back in. Or for visualization, we can also use the original geometry. What drives the calculations is this middle surface with the thickness. So when it's calculating stresses and anything else, it will use this data right here, which you will see a couple of those ribs are hard to see. If I used a higher mesh resolution, it would capture those. But with the level of detail I'm using right here, it will mostly ignore those. We can see a shadow of them in there. But for make it look pretty for the demo here, I'll use the original geometry. And just like with the cable simulation, we can add a visualization color coding if we want to for von Mises stress. So as we play through our motion later, we can see this update with our color map. You can also, just like cable simulation, you can create a value measure. And we do have a few less options here than we do with the cables. But we've got maximum displacement, von Mises stress, contact force, nominal length. Use any of those. I'll just add in a stress measurement there. And we've got our motion in here, and we have our rigid body here connected to that motion. To connect our bellow to this rigid body here, we just need to create a connection frame, which, there it is. We'll use this button right here. We have a connection frame. And now I'll select which boundary condition I want to attach that to. So I'll just drag that boundary condition onto the connection frame, and you'll see that line connecting them here in the scene tree. And I can drag that connection frame onto our rigid body. So now the connection frame is connected to our rigid body. The rigid body is connected to our motion. When we play through our motion, if I make it a little bit faster this time, a bit laggy today. There we go. Reset that again. We can play through the motion. We can see that color map update as we're going through. We can see, of course, the stress measure updates as we go through, just like in the cable simulation. And along those lines, we can still take that motion and we can use our analyze tool to plot whatever value measures we have on this bellow. So I'll just plot that stress real quick here. Take a few seconds. But as we pull up the graph here, we'll be able to search for maximum minimum values within the graph, just like we do in the cable simulation. And we'll be able to mark up things in there and export that graph to be used. Could be done in a second here. So we can see throughout the motion, there's the values our stress has, and if I want to find the place where we have our maximum stress, I can just use our little binoculars tool there. And I can see it's right here at the about 0.06, 0.07 seconds here. The other thing we can do from this graph with the dotted line there, and see if I hover over it, I get that cursor with the question mark.
Can you see that line up here?
And if I click on that, again, it'll tell us exactly what timestamp that's happening at and what the value of that stress is. And if I hit this go to button in the viewing window, it'll jump the scene right to that point in the motion. So also within the bellow tool here, we can still create those motion volumes. So if we go to, tools, motion volume, I can create a motion volume for the shell. I'll not include the engine components here. If we hit generate, that'll pull that up. And again, just like in the cable simulation, once we have that generated, we'll be able to export that geometry in a handful of different formats there. And we can still use that for checking clearances with other components as you go through the motion.
And question came in over there.
It's not there.
Can we do, the question is, can we do a torque test with this analysis? Similar to what we just saw here, like is suggesting like the max torque to be applied to avoid any deformation to the brackets. Then not certain any bracket to the bellow itself. I mean, I would think that if you're working one end, to get the bellow is front in on itself before loosing from the other side.
Yeah, we don't have a way to measure what specific values will cause the bellow to collapse, but if you have a motion with torsion in it, you can see that reflected in the motion once you have everything attached here. So you should be able to see in the animation the bellow collapsing if it's calculated to do so. So here course, I have our motion volume here. And if I hide everything else, we can still see that does capture the geometry, those ribs that weren't in that mesh. The motion volumes will still capture that. And you can see, you know, we have all the movement over here. And you can export that just like anything else. Hide that for now and bring everything back. So lastly, in this model here, I'll go through the contact handling. So this one, I've done all the same exact setup here just to move things along a little bit. I've also added in this primitive shape. And just so you don't have to watch me move that around so it's close, I brought this into another model here. So we have our contact handling enabled when we created the bellows here. We check that box. So if I take this cylinder here and I drag it around, if I try to collide with that bellow, we can see the bellow deform. And we can see that happen in real time here. And of course, we can also create a motion with something that would interfere with that. If you create a motion recording from that, you can see this in a lot higher detail. But even in real time, it's responsive enough to be able to drag things along and react. And as a little example here, if I can get it open. Here's some other types of bellows we'll use this tool with a lot of the times. So we have that air intake bellow right there. We also have bellows that are used for doors or rear hatches on vehicles there. And we can simulate all the twisting with the hinge there, the door motion. We've got different guides there. We've got steering rack boots, CV axle boots. And we can also do hard plastic fittings like this. As long as you put it, the material properties for some hard plastic, of course, we can form this one in the same way and do all the same analyses. And with that, I believe that's all I need to show you here, but do we have any questions? Two questions. Great.
My understanding is that external contact handling you showed it to us. Is there any work that's being done for it?
I do not know actually, but that's something we can check up on.
So I could go around it.
Mhm.
Not only the movement of the doing of the flexing that we want within it that would influence the stability of the tower.
Yes, yeah, I know we've had discussions about that, but I haven't personally done any work yet where we've had that bundle simulated in the middle of it. So, yeah, that's something we'll have to check out.
I'm looking at the green bellows and thinking about air suspension. Does this have the ability to, let's say, airbag related to suspension, so it would be something that would be filled with air, and as you compress it would be like words long, and you would see the actual deformation of the actual because of the pressure that's inside, or is that really affecting internal contact?
I think that would kind of get back to the same thing. We don't have pressure envelopes set up for bellows and grommets like we do for hoses. So I'm not sure you'd see that external deformation. You might be able to still see if you have somewhere you can define a start and end cap, some deformation from the motion itself. But I don't think we could look at the internal pressures right now.
Third question, so we brought it up the top, so if you related it back to that older cavity or the desk. If you were to model your grommet with all material properties and then couple it, let's say with rigid path planner, could you simulate the deforming of the grommet as it needs to compress to go through that hole to then snap back into the shape?
That is also a good question. We'll have to check on that as well. Yes.
I think it would depend on how extreme the decoration was.
theoretically. So like if you attach the rigid body to that connector for me, it's basically the clip. That's at least not outside of a simply and your foot, right?
Yeah.
It's still and then interacting with other geometries.
Yeah, if you maybe had a motion inserting it through that there, if you had contact handling turn on.
Yeah, and everything else. Kind of distracting. Deforming it.
Yeah, so I cautiously say, yes, we can, but I haven't done that yet. Anything else? Anything online? Alrighty.
Yeah, I'm someone was saying that
I have posted a question.
You have a question from external? Go ahead.
Sorry, we had a question online there?
Yes, I have a question. So the analysis, what you're doing over here, I think that's pretty much kind of a deformation and all what you're trying to analyze. So what I want to ask is, can you do a similar one in IPS to kind of do a torque test? Like in manufacturing, we use various torques to, let's say, secure one bracket to another. And there should be a certain amount of torque which will be provided to avoid any deformation. And I mean, can we have those analysis done over here? I mean, through IPS, any torque test available?
If I understand the question correctly, I don't believe we have analysis tool specifically for that. And I don't think I can show you the model we've done this with another customer, but we have looked at grommets, somewhat like this one here with this bellows section on a rear hatch. And yeah, like I said, when you attach it to a motion, we can see at what point through the motion there, the bellows starts to collapse from torsion. And if we take a look at the analyses we do have in here, we can see at that point in the animation what sort of torsion or stresses we're under there.
Yeah, but with no torque, right? I mean, nothing related to the torque.
Yes, it'd be more forces for bellows here.
Got it. Yeah.
I don't believe we can do that with bellows. We can with cables. Here we have visualization, color coding, displacement, von Mises, equivalent strain, and contact pressure. You can also look at relative displacement.
So in second, we're talking about concepts. Anselm's comment is regarding internal contact cable inside of the grommet. It does not work, but rigid body inside grommets. Check on that, but it believes it does work. So, great. Well, thank you for the demo, Scott.
There you go.
And thanks for your questions out there.
Yes, yes, thank you. With that, I believe I'll hand it back to John here.
So we're going to bring the whiteboard in, but there's two things that we want to focus on here. One is, I think during the day, you guys had some the tool do this or do that or what it is, right? Yeah. So I think we want to capture those and then we want to take them back and find out either from our team in Germany, team in Sweden, or even our own internal team, like, can it be done? This is something we can try. The other part of this is like, there are things I know you guys are looking for in terms of enhancements, like, for example, we're solving, right? That's one of the things that we want to see, so that's on our list of like wishes of things to do. So so we want to capture that from you guys as well, is that all right? Because we want to be able to apply this, to maybe the development life cycle for this particular solution, or what's on their technology roadmap, and where does that fit in development. So those are the two things we want to capture. Is that fair? Okay. So Sonia, I'm gonna go to you in front of me.
Rotate.
Yeah, I'm gonna get out of the way. So. All right, so the first question I have for you guys have a list of like, can we do things, right? So can we get a list of those? Like, what are the things that can we do this, right?
I'm ready.
Go ahead, email, just go ahead. Do you have any, Bruce, do you have one?
I did ask one question. I was thinking to, but it's answered, no, it's color code, melodies, sort.
That's not me, but.
For forces.
Yeah.
Bruce.
Okay.
Hello, Brandon.
John? I know.
It's color. It's not color code, it's color code.
Color map.
Thank you.
Your top five.
More important exportability options for other PEMs and PLMs. And then just the question of motion.
Yeah.
PLM.
What specifically about motion?
You basically to go from a VFM world into other worlds of. You talk about this.
Yeah, motion.
John, how do we read that down? Translate that for us.
Motion down.
I was scared. You started that.
It's really like,
That's
John?
that was all. That didn't happen for now.
I'm trying to figure out how to explain this one. So what I was saying earlier with the being able to manipulate the host outside of motion files manipulation, like as though for an object came in and hit it, poked it around a bolt, and then the motion continued, and caused too much tension in it. So, can you translate?
Yeah.
Yeah, so when we first partnered with fleXstructures in 2020 and started working in software, I always thought it would be nice to just limit, basically force the cable to remain at its nominal length. Which is kind of what you're talking about, right? I wanted to stay the nominal length and just bag it around and see where it can go with that nominal.
Yeah, or within an elongation limit.
Sure, yes. Elongation limits, I guess.
Envelope, elongation limit envelope.
Yeah, so I think the force envelope, which is what,
Yeah.
I don't know who's, somebody suggested.
Yeah, so it's brought it up. Yeah, it's a response to me.
Yeah, so I think that could be a great tool for that. But it would be nice if you could just say like, no, don't allow it to elongate more than 1%.
Yeah.
And then you strand it around.
Well, the other thing too that we'll do is we'll hook it around something, right? And then you move the suspension to see if it's self-relieving.
Oh,
Because that's critical. If it's self-relieving and it's like a soft surface, sometimes it'll pass, depending on the likelihood of the occurrence.
Yeah.
So
I don't know about that. I don't know how to phrase that, but all right.
well, we all got it up here.
Yeah. Ari, I'm gonna ask you guys.
Computationally lighter solver.
All right.
That's more wish list.
Yeah.
All right.
It seems like it's coming.
Yeah.
It's